question is, if I assume, and this is an assumption, don't forget, if I assume that y is equal to alpha plus beta x plus epsilon, how come I can write beta hat in that particular form? The first thing to know, which I am not going to derive, okay? I will not derive this, but it's in your lecture notes. You should know how to derive this, is that the beta hat OLS is equal to the sum xi minus x bar yi minus y bar over sum xi minus x bar, all of this squared, okay? This formula only includes data or things that are observable, okay? Everything here is observable. Observable. And this thing holds mechanically. In other words, I don't need this assumption for this formula to work. Okay? For this formula to work, the only thing that I need is that the x's have variance, okay? That the denominator of that formula is not 0. That's the only thing that I need, okay? But I don't need that assumption that the model is linear, okay? Now, if I impose that extra assumption, can I make any progress? Well, let me kind of cheat here a little bit, okay? Let me cheat here a little bit. The question asks you to go from beta hat to something that has both beta and epsilon, okay? Does this expression that you have here have beta and epsilon? Yeah? Exactly. I could replace y with what I'm looking for, okay? I could replace y with what I'm looking for. And I'm also going to do one little trick here as well, just to make my life a little bit easier. Can everybody see why this is the case? Why is that the case? Someone else. Yeah.
So you multiplied the numerator up, and
Yeah.
then you would have y bar times xi minus x bar, and that whole summation equals 0.
Correct. So if you were, the answer is, if you open up the numerator and you multiply yi with this bracket and you multiply the y bar with this bracket, because y bar doesn't depend on I can pull it out of the summation. And one properties of summation notation is that the sum y bar xi minus x bar, what you should remember from the first lecture that Jordi did and from some of the videos that I've done on summation notations, if you go look at them, this thing here will equal to 0, okay? Did you look at my videos? Excellent, right? It's incentives to look at those videos, right? You will know the answers to things, right? If you look at them. So that's the first thing to realize. And the second thing is, at this stage, again, this is mechanical, but at this stage, I can say like, oh, let me plug in what yi is, which is simply alpha plus beta xi plus epsilon I over sum of xi minus x bar, all of this squared. Agree? Excellent. Once you've done that, look how easy your life is. When alpha multiplies with this, what are you going to get? 0 for the same principle. So then this thing here will become sigma xi minus x bar. Beta can go out because it's a constant, xi plus sum of xi minus x bar times epsilon I. Is this equal to 0? Of course not, because epsilon I is not a constant. I cannot just pull it out, okay? So this is not going to equal to 0, so I'm going to have to leave it there. And this thing is going to divide by sum of xi minus x bar, all of this squared. Well, let me do something. let me divide this into two groups. So let me do this. Can I do that? Nothing that prevents you to do that, right? Well, it's starting to look similar, right? At least I've gotten this part here. This part here I've gotten it. Okay? But this part here I've not gotten. Well, the numerator and the denominator seem different. Can I cancel them out? They certainly look different. It's not the same. Yeah, Dragos.
I've managed to prove that they're all equal by writing them out on the line. They were writing sum of xi minus x bar squared equals, minus sum of xi minus x bar multiplied by xi. I've shown that they're equal to 0, that the difference is equal to 0. But I don't know how to prove it.
Okay, anyone else? They don't look similar, right? I can't just do this, right? I can't just say this and this will cancel because they don't look similar, okay? Anyone that disagrees with me? Yeah.
If you expand out the brackets, you can cancel them as well because it will be multiplied by constant.
Okay, like if we expand out the bracket, we could also do something, but let me do something that's easier than expanding out the brackets, okay? Remember what I did here? I got rid of the y bar, right? Because the y bar times this was just a 0, okay? So with exactly the same idea, with exactly the same principle, can I do this? Of course I can, because x bar times that summation notation will just be a 0. It's the reverse of it. Then it's very obvious that this bit here is exactly the same as this. So this 2 can cancel out, and you're left with beta. Now, I'm exaggerating here when I'm saying this is obvious. Of course it's not obvious. If I was in your position, right? Of course I wouldn't have immediately seen that, okay? The only reason why this is obvious to me is because I've done it a few times, okay? And the idea is that once you do it a few times, it will also become obvious to you as well, okay? And that's the whole, that's the whole purpose of kind of practicing with this and just doing it a few times. But here's an exercise that might have looked very ugly and difficult that is actually not at all difficult, and all that you're using are properties that Jordi has introduced in lecture 1. From a math perspective, everything that was introduced in lecture 1, you're going to be using it over and over again. So I'd highly recommend that you go back to that lecture 1, you go through slide by slide. If there's anything you didn't understand, you bring those questions to class, okay? And on that note, that concludes that.